In this video, we're just going to run through the solutions of the Exam 3 review sheet. And our first problem simply says to square this. And we know squaring something is multiplying it by itself, so we have 7a minus 9b times 7a minus 9b. And now we know we have to FOIL, so we have 7a times 7a, which is 49a squared. 7a times negative 9b, which is minus 7 times 9 is 63ab, and then we have minus ab minus 9b times 7a. 9 times 7 is 63 again, so we get minus 63ab again. And our last thing is a negative times a negative, which is a positive. 9 times 9 is 81b squared. And our last step is to combine like terms, which we only have in the middle here. So we have 49a squared minus 60 plus 60 is 120, so 126ab plus 81b squared. And that's number one, just testing to see if you know how to FOIL. Number two is a basic factoring problem. Here I'm going to use the slide, divide, slide method. So the first thing I'm going to do is slide this 7 over, and I get x squared plus 19x plus 70. And I say what two factors of 70 multiply together to equal 70, but add to equal 19. So I just start checking them. 1 and 70 doesn't work. 2 and 35 doesn't work. 3 is not a factor of 70. Is 4 a factor of 70? It's not. Is 5 a factor of 70? 5 and 10, 11, 12, 13, 14. And we found our answer. So once we have two numbers that add up to equal 19, it is x plus 5, x plus 14, because we have all plus signs. And now I need to take my original 7, take the 7 that I slid, and divide it. Now the first term stays the same, x plus 5 over 7. The second term, 14 over 7, gives me a 2. And now that I've finished my first slide, finished my divide, I do my second slide, which is take any fraction that's left here and bring it to the front. And I get 7x plus 5 times x plus 2. And that is my full factorization. Now if I move on to number 3, my first piece of number 3 is the square root of 120 x to the 11th y to the 4th. So we'll do the variables first. And I like to think of the square root symbol as a classroom. This is a square root, so it's powers of 2. So in variable terms, it's just saying take all the y's and leave in pairs of 2. Any pairs of 2 that can leave as a pair. So how many pairs of 2 y's do we have here? Well, we have 4 y's. So if you imagine 4 y's sitting in a classroom and the teacher says pair up and get out, you have 2 pairs. So we're going to have y squared on the outside. If we have 11 students in the classroom and the teacher says to get into groups of 2 and leave, how many groups of 2 can leave? Well, if there are 11 students, we'll be able to make 5 groups of 2, but there will be 1 x left over. No one wanted to pair up with that x, so it has to stay in the classroom. And lastly, we have the 120. 120, we'll factor it and see how many pairs of numbers can leave here. I'll immediately bring it down to 10 times 12. Then with 10, I'll bring it down to 2 times 5. 12, I'll bring it down to 2 times 6, which is 2 times 3. So I see that if I circle my 2's, I have 1, 2, 3 2's. So I know that 1 pair of 2's can leave. So I have a 2 out front. And that gets rid of 1 pair of them, but I still have a 5, a 2, and a 3. If I multiply that all together, it's 30. And this is my answer. I have a 30 left on the inside, I have a 2 on the outside, I have a y squared on the outside, an x to the 5th on the outside, but 1x stayed inside. And I follow that same rule with the next one. This is a y to the 9th. I just have very bad handwriting. Y to the 9th. I follow the same rule with the next one, except this time the teacher said to leave in groups of 3. So let's do the y's first. How many groups of 3 y's can leave if there are 9 y's in the classroom? Well, 9 is 3 groups of 3. So we have y to the 3rd, or y cubed. And then if we look at the x values, the teacher said get into groups of 3 and leave. How many groups of 3 could leave? Well, 3 groups of 3 could leave, but how many x's are left? If 9 of them left the room, there are 2 x's left inside. There were not enough to leave in groups of 3, so those 2 have to stay inside. And then we factor 108 just like we factored before. 108 is 2 times 54. 54 is 2 times 27. 27 is 3 times 3. Well, 9 times 3, which is 3 times 3. So I say, how many 2's do I have? I only have 2 of them. That's not a group of 3, so they're going to have to stay inside. So I know that I have at least 2 2's inside. But if I look at my 3's, I have 1, 2, 3 of them. I have a group of 3 3's. So they can leave as a group. And then I have my 2 times 2 left, which I'll put on the inside, which 2 times 2 is 4. And that is how you simplify these. Number 4 is another one that we're just going to factor. I'm going to do the same method. I'm going to multiply 4 from the front to the back. I'm going to slide the 4 over and get n squared plus 17n minus 4 times 15 is 40 plus 20, which is 60. And this time we need 2 factors of 60 that subtract to equal 17. So 60 minus 1 is not 17. 30 minus 2 is not 17. How about 3? 3 and 20. 20 minus 3 is 17. So we get n, and we need the bigger number to be positive because they need to subtract to equal positive 17. So n plus 20, n minus 3. And we did our slide. Now we do our divide. Divide back the 4 that we slid at first. This time the first term can simplify. This is n plus 5, but the second term can't. It stays as n minus 3 over 4. And our last step is to slide back. And the only thing that we can slide back is this 4 in this case. So we get n plus 5 times 4n minus 3. And that is number 4 factored. Number 5, there's a slight typo. It says which of the following is a factor of, but it means to say just to factor it. So let's factor it. Same method, multiply the 9 by the 12, and I get y squared plus 52y minus 9 times 12 is 108. And I do the same thing. I need 2 factors of 108 that subtract to give me 52. So 108 minus 1 is not going to be it. 54 minus 2 is it. So that time I only had to check 2. And it has to be positive. The bigger number has to be positive again. So we get y squared plus 54, not y squared, just y, plus 54 times y minus 2. And we slid a 9 at first, so let's bring that 9 back. This is the divide part. Now we simplify. 54 over 9 is 6. 2 over 9 doesn't simplify. And then we slide back. The only thing we can slide is this 9 back to the front. So we get y plus 6, 9y minus 2. And that is my factorization of number 5. Number 6 says to factor, and you might immediately see a bunch of powers and a subtraction sign and think I need to do the difference of squares method. But let's pull out everything they have in common and see where we're at. I see that they have a 5 in common, the two terms. So I'll pull a 5 out first, and I get 5 times x cubed minus 7x squared. Now I see that both terms have two x's in common, so let's pull two x's out and get 5x squared times x minus 7. And this is fully factored because x minus 7 is to the first power, so there's nothing to factor out here, and neither term has anything in common with the other, and 5x squared clearly can't be factored further, so this is just our solution. Now moving on to number 7. Number 7 is just a rationalizing the denominator problem, which is something that you have thought a lot about in the last couple weeks. And to rationalize the denominator, we just utilize the fact that we know a plus b times a minus b is equal to a squared minus b squared. And what that gives us is it allows us to square this term and square this term, which will get rid of the square roots in the denominator. But remember, if I'm multiplying by, this is a minus b, so a plus b is 2 root 7 plus 2. If I'm multiplying by that on the bottom, I have to multiply by it on the top. So on the top, we just get 3 times 2 root 7 is going to be 6 root 7. 3 times 2 is going to be plus 6. And on the bottom, well, I know I'm going to get a squared minus b squared, so you're welcome to FOIL it, but I have this little trick that tells me I'll have this squared, which is just 4 times 7, minus b squared, which is minus 4. And now I simplify. This is equal to 6 times root 7 plus 1 over 4 times 7 is 28 minus 4. And 28 minus 4 is equal to 24. So I see right away that I have 6 over 24. So this fully simplifies down to root 7 plus 1 over 6 over 24 is just 1/4. So it's over 4. And this is my fully simplified, rationalized denominator, problem 7. Number 8, we just want to simplify this. We want to make it look a little prettier. So what I do is I'll factor the numerator and the denominator and see where we're at. I see that we have 4x's here and 2x's here, so I can pull 2x's out on the top and get x squared times 14x squared plus 1 over 3x squared. And now that I have multiplication in my problem, I can start to cancel things in the denominator and the numerator. Namely, I see that I have an x squared here and an x squared here, so they can go away. And my solution is 14x squared plus 1 over 3. With number 9, we're once again factoring this. So this is equal to, I can pull a 3 out. And if I pull a 3 out, I get 2y to the 5th minus y squared. And then I can focus on the variables. I see that I can pull 2 y's out, which gives me 3y squared times 2y cubed minus 1. And that's all I can do with number 9. Number 10 says to add and simplify these fractions. And in order to do so, I know I need a common denominator. And that common denominator is going to be the least common multiple of 9 and 5r. And if I throw it in the division box, 9 and 5r, I immediately see that I can't pull anything out. So my common denominator is just going to be 9 times 5r, or 45r. 45r. And then I just say, what do I have to multiply 9 by to get up to 45r? Well, I have to multiply by 5r. So we have to multiply this by 5r. 4r times 5r is going to be 20r squared. And then I say, what did I multiply 5r by to get up to 45r? Well, I had to multiply by 9. So I'll multiply the numerator by 9. And 8 times 9 is going to give me 72. And my solution is 20r squared plus 72 over 45r. Continuing. Number 11 is very similar to number 8. It's just kind of flipped. So with number 11, I factor the numerator and denominator. Numerator can't be factored, 8a cubed. But the denominator can. I see that I can pull a 2 out, so I'll have 2 times something. But I also see that I can pull 2 a's out, so I'll have 2a squared times something. And what's left when I take a 2 and 2 a's away from here? Just an a, plus divide 8 by 2 and I get 4. Take away 2 a's and that's all the a's that are there. So this is what we get. And I immediately see that I can divide 8 by 2 comfortably. 8 divided by 2 is 4. And I also see that I'll have 2 a's here, 3 a's here, so I'll have 1 a left on top. And on the bottom, I'm left with this piece as well, a plus 4. And that's number 11 simplified. Moving on. Number 12 is another just adding fractions problem. All we have to do is find a common denominator, and we can kind of already see that denominator is going to be 9, because 3 is a factor of 9. So I'll just take this one and multiply top and bottom by 3. And I get p over 9 plus 3p over 9 is equal to p plus 3p is 4p over 9. And that's all there is to number 12. Number 13 is kind of the inverse of number 12, but it actually makes it a little more challenging because I have different denominators this time, and I don't know what their factors are. I don't know what any factors of p are or factors of q, or if they have anything in common. So my common denominator is just going to be p times q. P times q. And I see that I had to multiply this p by q, so I'll multiply this 9 by q, get 9q. I see I had to multiply this q by p to get to our denominator, so I'll multiply this 3 by p, and we'll get 3p. And this is just going to be equal to 9q plus 3p over pq. It condenses, but we don't really lose anything. And that's number 13. Number 14 has a little bit of practice with fractional roots. I know that a negative root is immediately going to flip me like this. 9 to the negative 1/2 is going to be 1 over 9 to the positive 1/2. It's going to give us the reciprocal. And 64 to the 2/3, if I do something with that, it's going to be the third root of 64 squared. So we need the third root of 64, and we need to know what 9 to the 1/2 is. Well, 9 to the 1/2 is root 9. And what is 64 to the 1/3 power? Well, we can figure that out by factoring 64. 64 is equal to 4 times 16. 16 is 4 times 4, so we see that it's 3 4s. So the cube root of 64 is just going to be 4, and we get our square. And then this is equal to 1 over root 9 is 1 over 3 times 4 cubed is 16. So this is equal to 16 over 3, or 5 1/3. The next piece of 14 is just to square everything here. If I square the 16, 16 times 16 16 times 16 is going to give me a 6, a 3, 6, 7, 8, 9. Add a 0. 6 times 1 is 6. 1 times 1 is 1. 160 plus 96 is 256. So I know 16 squared is 256. And z plus 4 squared, the square root of z plus 4 squared, is just going to be z plus 4. Because the square and the square root are going to cancel. And this is all I get. I could multiply the 256 in, which would be 256z plus 256 times 4 is 250 times 4, which is 1,000 plus 24. So 1,024. So either one is a good answer, as long as we get rid of the roots. This next one you might have overthought. The square root of a to the 5th squared. Well, the square root and a square just cancel with each other. So we're left with a to the 5th. Moving on. Number 15. Number 15 is another one where we have to find a common denominator. And in this case, our common denominator needs to include a 3g, needs to include a 3, a g, and a g minus 8. So our common denominator is just going to be 3g times g minus 8. 3g times g minus 8. And then we say, what was this one missing? It was missing the g minus 8, so we'll multiply the 4 by the g minus 8. Plus sign. What was... change my color. What was this one missing? Well, it was missing the 3g, because the 3g was over there. So we'll multiply the 8 by the 3g. And we get 4g minus 32 plus 8 times 3g is going to give me 24g all over 3g, g minus 8. Now 4g plus 24g is going to be 28g. 28g minus 32 over 3g times g minus 8 is what I'm left with. And I see that this has no factor of 3, this has no factor of g. Together they have no factor of g minus 8. So I have nothing I can cancel, so that's just my answer. With number 16, we need a common denominator again, but we have something that's factorable. And anytime we have something that's factorable, we know that we should factor it. So let's factor it. X squared minus 12x plus 32 needs two numbers that multiply together to equal 32, but subtract to give us negative 12. 1 minus 32 is not negative 12. 2 minus 16 is not negative 12. 4 minus 8. Oh, negative 4 minus negative 8. Negative, 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 negative. Sorry about that. We have a plus sign here, which means our signs are going to be the same. And we have a negative sign here, which means our signs are going to be negative. So we need two things that add up to give us 12. And negative 4 plus negative 8 gives us 12. Negative 12. So we have x minus 4, x minus 8. So we can rewrite our problem. Our problem is 1 over x minus 8 minus 2 over x minus 4, x minus 8. And I do need some space. And so we see here that our common denominator is clearly going to be x minus 4, x minus 8, x minus 4, x minus 8. We have a minus sign. And we say, which part of that is this piece missing? It has the x minus 4, but it doesn't have the x minus 8, so we'll have to multiply our 1 by x minus 4. And then the term on the right actually isn't missing any piece. That's just our common denominator. So the 2 can stay alone. And we get x minus 4 minus 2, which is equal to x minus 6 over x minus 4, x minus 8. And we can't cancel anything, so that is just our solution to number 16. Number 17 is a little more scary. You see this big ugly fraction. But the fraction bar works exactly like the equation equal sign. And when we see equations with fractions, we just get rid of them. So let's do the same thing here. Let's multiply the top and the bottom by some common denominator that will get rid of all of our fractions. That common denominator must include an x squared for sure. It has to include an x squared, which it already does. It has to include a 2, so we'll add a 2. And it has to include an x squared. And anything we multiply the top of a fraction by, we also have to multiply the bottom of the fraction by. And we see that with our first term, 8 over x squared times 2x squared, let's write it all out. This is 8 times 2x squared over x squared plus 4 times 2x squared over x squared all over 3 times 2x squared over 2x squared plus 4 times 2x squared. All I did here is I multiplied these 2x squareds in, and now I can cross things off. I can cross off an x squared here with an x squared here, an x squared here with an x squared there, a 2x squared with a 2x squared, and it looks like that's all I can cancel. So I'm left with 8 times 2, which is 16, plus 4 times 2, which is an 8, over 3 plus 4 times 2x squared, 8x squared. And it makes my fraction a whole lot prettier, because I know what 16 plus 8 is. 16 plus 8 is just 24 over 3 plus 8x squared, and we're done. So as long as we treat the fraction just how we treat equations, we are good. Which leads us to number 18, when we have to do our equation rule. In this case, you could very easily do 6/8 plus 3, then add 6 to the other side, then multiply both sides by x and see where you're getting. But that's a lot of hard math for no reason. Instead, something that we could do is multiply everything by a common denominator, or an x and an 8. Which, if I write it out, gives me 2 times 8x over x minus 6 times 8x equals 6 times 8x over 8 plus 3 times 8x. And I do that because I can cross off an x here and an x here, an 8 here and an 8 here, and suddenly my problem has no fractions. What I'm left with is 2 times 8, which is 16, minus 6 times 8, which is 48x, and that's equal to 6x, plus 3 times 8x, which is 24x, which gives me 30x over here, which is equal to 16 minus 48x. I'll add 48x to both sides, which gives me 16 equals 78x. Divide by 78, and I get 16 over 78 equals x. Now I see that I can simplify this, so I can divide them both by 2, and say that this is equal to 8 over 35 plus 4, 39. And that is our review sheet. A whole lot of simplifying, a whole lot of crossing things out, which are my favorite things to do in math, so I hope you're enjoying yourself.